Smart means to be able to think quickly or intelligently in difficult situations. If we are facing any problems or difficulties, then we would use our brains to use our smartness to think of a solution to solve that problem. Would you believe if I said that there are hundreds of materials around us that are smart and intelligent just like us? Well, they can't solve solutions like us, but they can adapt to the environment around them. What are those materials? The materials are called smart materials. The intelligent type of materials that can change their properties, whether it is temperature, volume, size, or even color, based on the changes that occurs in their surrounding. These materials can be used in many cool applications. Let me give you some examples. Have you ever seen a person wearing a transparent pair of glasses that suddenly turns darker during the day? Well, those glasses are made from photochromic materials. Photochromic materials are one kind of smart material that can change their color based on the amount of sunlight that passes through them. In the morning, when there is less sunlight, the glasses are transparent, but when the day becomes brighter, the glasses becomes darker to block sunlight from glaring your eyes. As cool as the photochromic materials sound, there is one particular smart material that I'm interested in. The material is called Electrochromic Material, a unique type of smart material that can change their optical properties from initially being transparent into an opaque state. Just like the photochromic material, but this time they change with the flow of electricity. They exist as smart films and smart glasses, where they are initially transparent, but when we apply electricity, they can turn into opaque or tinted. What is so unique about electrochromic materials that I use them to apply them for my final year project? Well, besides their 9 million market size, they use electricity to change their state, which allows us to control this change of state. We can control the amount of electricity to make it opaque, transparent, or even in between them. Unlike photochromic material, they can only change based on the amount of sunlight that passes through them. When the electrochromic film is opaque or tinted, it doesn't just reflect 99% of ultraviolet light, but the heat is also absorbed and captured inside the film and radiated upwards, protecting us from the harmful ultraviolet rays, which can cause skin cancer, the 10th highest cancer cases in Malaysia. Its ability to block sunlight is also very crucial to help us prevent us from seeing the glare of the sun, which can cause 9,000 road accidents in our country each year. Besides that, the film is very easy to use. We can just stick it to any existing transparent surfaces, or if you don't want to use it, you can just pull it out like a sticker. To prove this, I have built a smart house prototype where I apply the smart film to show the connection between the smart film and the system of the smart house. To make it more novel and more advanced, I embedded the smart film with IoT monitoring system that involves UV sensor to measure ultraviolet light, PIR sensor to sense any movement, and also temperature and humidity sensor to measure temperature and humidity. I placed the smart house prototype on an open environment on a hot sunny day and placed one temperature sensor and one UV sensor inside and outside of the house. This is very important for me to measure and calculate the difference in temperature and ultraviolet light. Every 15 minutes, I will take the reading and plot graphs to make analysis. As you would expect, the ultraviolet radiation was successfully decreased by 30%, and the difference in temperature was a constant decrease of 10 degrees Celsius. This proves that my smart film device is capable of blocking ultraviolet light and also controlling the temperature inside the house while maintaining the privacy of the house, which can be controlled by smartphone applications. So what now? Well, this project has been awarded in many invention competitions where I won gold, silver, and also best final year project, which shows how important my project is for our country, Malaysia. Even though this smart film isn't commercially used yet, but with my small effort, we can change the use of blinds and curtains into this much smarter application. So, why live hard when you can live smart?